Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Good, Mr. Q? All right, good. You guys noticed that it was cooler in the morning now? Let's go. Bring it on. Well, it's always cool in here, but I'm saying now they're kind of matching our vibe outside. So, warm-up number 32 is on the screen. By now we are experts at this, so I'll give you guys some time to copy and finish that up. Get started, please. Copy and go. All right, here we go. For the sake of time, I'm going to go over the entire warm-up. Says simplify to lowest terms. So, GCF between 4 and 20 is what, everyone? GCF is what? 4, yeah? So this could be written as 4 times 1, and this could be written as 4 times 5. Is that correct? All right, so giant 1, answer 1/5. 1b. I need to factor first the numerator, 6 and 5, factors of 6 that add up to 5, that's 2 times 3, or 2 plus 3. So my factors are x plus 2, x plus 3. Let me factor this one, -10, -3. Factors of -10 that add up to -3, that's -5 and 2, yes? So that means x minus 5, x plus 2. Giant 1, the x plus 2 is a giant 1, Mr. Q, and that leaves us with x plus 3 over x minus 5. And have you got that? Yeah, some of us? All right. Number 3, factor. -18, -3. Factors of -18 that when you add them give us -3. Factors are, oh, I like this one. Let's go. -6 and 3, is that correct? So therefore, x minus 6 and x plus 3. So far so good, yeah? You're like, oh snap, Mr. Q, this looks weird. Yes, but can we factor it? Yeah, what's GCF for these two? 2, that leaves us with x squared minus 16. Can I factor the inside? Well, does it have a minus? Yes. Is it a squared? Yeah, let me check. What is square root of x squared? X times x. What is square root of 16? +4 and -4. That is correct. Bring down the 2. There you go. Hands if you got that. Let's go. Number 4. Number 4. That's pretty good, right? Let's go. Oh yeah, they don't mess with me. -3y minus 3. Oh no. We need to solve for y. My bad. I did that to see if you guys were paying attention. We add x to each side. Add x. 3y equals x plus 4. And then at the end we divide by 3, divide by 3. So my new equation is y equals 1/3 x plus 4/3. I'm going to leave it in fraction form just so that we can work with those numbers that we have there. Okay? All right. So we need to substitute for x what values? -3, 0, and 3. So y equals 1/3 times x plus 4/3. I'm going to do that 3 times. 1/3 times x plus 4/3. Y equals 1/3 x plus 4/3. Okay. So here we go. My first value is -3. So what is -3 times that 1? It's -3. What is -3 over 3? That's -1 plus 4/3, or 1 and 1/3. That leaves us with 1/3. Next value, 0. 0 times this is 0. plus 4/3, and the answer is 4/3. Last but not least, 3. What is 3 times this 1? That's 3 over 3, which is 1 plus 4/3. So if we make this into thirds, so that is 7/3. Yes? All right. Last but not least, number 5. What's GCF for these two? What would be GCF for these two, Jesus? 6. So this is 6 times 3. This is 6 times 1. Therefore, let me rewrite this. Let me bring down the 6 times 3, 6 times 1, the 8, and the 5. Question, look up. We need to make the denominators look the same. So what does this one on the right need from the one on the left? Okay, what does this one need from over here? The 3. So we multiply top and bottom times 3. So now, what does this one need that this one has? 1 and 1. All right, so let's rewrite that. 6 times 3 times 1 is 18. 18. This is 8. This is 15. 18 common denominator. 23 microjoules. Let's go. Oh yeah, we got this. Rachel. Let's go. All right. Copy the agenda, please. Warm-up number 32. Adding rational expressions. And tonight's home play sheet Q, numbers 1 through 8, all only. Now, today we are moving on. We are starting our second semester stuff. Now, let me just give an observation in passing. I don't want to make it a full session. I'll probably do that on Friday. But today, the only thing I'm going to mention from quarter 1, reflecting on quarter 1, think about it. What is the one thing that you learned from quarter 1 for you to not relate to mathematics, but in regards to your approach to your courses, specifically my class? What did you learn? Anything that you learned, keep that to yourself. One thing that I learned is that some of y'all need to start putting in some more work, because you're going to see today that some of the work that we did in quarter 1 is going to start adding up to what we're going to do today in quarter 2. And it continues adding and adding. Second, the work that I give you for the warm-ups, guys, that's practice. I'm actually telling you to run some laps with this. If you're not doing this, by the time we get to the lesson, I don't know what to tell you. And some of you that are consistent with this, you're like, when we get to the lesson, you're like, let's go. Why? Because a lot of the practice is in here. Please, pretty please. And last but not least, copy this code, ZSVMC. ZSVMC. And that's going to be for your home play access. Now, over the weekend, I was looking through through my notes from last year. Then I saw that last year I covered 2 skills in one day, but then I noticed that for some it was a little bit overwhelming, so today I cut it in half. So we're doing 1 skill today, and we're doing another skill in 2 days, because I want us to do extra practice tomorrow. So, moving on today, look at your home plate. Let's go. Let's go. Bring it, Q. Oh, yeah, we got this. So, all right, get a Cornell note ready, please. You don't need a Freyer model. And for this one, we don't need our Chromebooks out. You can put those away. Thank you. Appreciate it. Yeah, because it's going to have a lot of little components that I want to make sure that you are, your full attention is given to what we're doing. Not that I don't trust you and that you're doing other stuff, playing games or such. So, y'all ready? Yeah? Okay. So, our objective for today, I can add rational expressions. I can add rational expressions. So, we're still on the same concept, rational expressions. So think about it. Remind your neighbor, what are rational expressions? Remind them, what are rational expressions, neighbor? Looks like Gio's got it. Very good, Gio. I see you. Mario's got it. I see you, Mario. All right. Let's go with Elijah. Rational expressions are polynomials with numerator and denominator. So a fraction with polynomials. All right. Yep. So we cover that. There they are. You did a poster last week. You did a pop parte that I still need to correct. Right. All right. And I gave you guys the definition to get started with rationals, which is this. Okay. And what did we say? That the denominator cannot equal to 0. That's part of the definition. And what is that called when we start finding those values for the denominator? For the denominator? Because I saw some posters, some of you were like solving on the numerator for x. You know, like, you don't solve for x on the numerator, only the denominator. What are those called? Excluded values. We're going to be using those as well. However, today we're going to follow this step. So, since it requires more processes, I want you to write the steps down, please, on your paper. And then read steps. Number 1, factor the denominators completely and identify the least common denominator, or the LCD. Step 2, rewrite each fraction and add or subtract. Step 3, simplify to lowest terms after you identify all giant ones. And step 4, identify excluded values, which means write the denominator equal to 0 and solve. So copy those steps. I'll give you some time, and that's exactly the process that we're going to use for today. So, once again, step 1, factor the denominators completely and identify the common denominator. Step 2, rewrite each fraction and then add or subtract. Step 3, simplify. And step 4, identify excluded values. Ready, Mario? I'm going to start you guys slow. So, copy this one, please. Example Q. It says, add or subtract, identify excluded values. We got 2n over 5n cubed plus 4n over 2n squared. Copy that. Only I'll guide you through this one. Writing utensils down. Once again, you don't need your Chromebooks. Put those away. Stay focused, because it's going to get funner, like really quick. So right now we're in our beach cruiser. Feel the wind hitting you. We're in Ocean Beach right now. Just had a burrito from this place in the corner over there. I remember I used to live like half a block from the beach at OB. Can you believe that? Let's go. But we actually rented a house between 12 of us. 12 people, imagine that. All right. Start with the first step. Look up to the screen. It says, factor the denominator completely. And right now you're just paying attention. You'll copy right after. Once again, writing utensils down. Put away those Chromebooks. Here we go. Denominator. How can I write this in factored form? Well, 5 times n times n times n. How about this one? 2 times n times n. Are we there so far? All right, well, step 1 is done. But we need to identify the last part, which is what? The common denominator, which means this denominator needs to look the same as this one. It's close, but not quite. What does this one need from over here? A 5. What else? And 1n. So that means I need to multiply this one times 5 and 1n. Is that correct? Whatever I do to the denominator, I do to the numerator. Are we there so far? Next, what does this one have? Look at it. That this one needs. The 2. Whatever we multiply the denominator, we multiply the numerator. Are we there so far? All right, copy that, please. All right, so step 1 is done. We factored the denominators. Yes, Mr. Q, right here. And then we identified the LCD. The LCD, now they look the same. That means we have a common denominator. All right, next, I'm going to step 2. Writing utensils down, look up to the screen. Look up to the screen. Y'all ready? Here it goes. It says rewrite each fraction. So, this fraction first. The denominator now is all this. Yes? Which means I'm going to write 2 times 5 times n times n times n. This one is 2 times 2 times n. Does everybody see that? This one now. The denominator is 2 times 5 times n times n times n. Numerator, 4 times 5 times n times n. Copy that, please. All right, so let's do the next step together. Let's rewrite this now as a common denominator. So what is our common denominator, people? 10 what? N to the third. 10 n to the third. What do we have in the numerator for the first one? 4n. How about for the second one? 20n to the what? To the second. That is correct. All right, so step 2, done. Let's go to step 3. Oh, my bad. The second portion is to add or subtract. So, common denominator is 10n cubed. Same denominator, yeah? So, we focus on the numerator. 4n plus 20n squared. So, I'm going to write it in standard form. Instead of writing 4n plus 20n squared, what do I write? 20n squared plus 4n. All right? So, with that said, let's go to the next step. Let's do the next step together. Simplify to lowest terms. How do we simplify? Well, look up, please. Can we find a GCF between 20 and 10? What would be our GCF? What would be the biggest number that divides 10 that divides 20? 10, right? So that means I can write 20 as 10 times 2. Yes? All right. So that's the 20, but we have a GCF. Can I get the GCF out? Yeah, let's do the GCF first. Sorry, I went ahead of myself. My bad, my bad. GCF here. 4n. So that leaves us with 5n plus 1. and I'm left with 10. I'm going to write it. And then n, let's write the n factored out. N times n times n. So you guys can see it. So now here's where we ask, what would be GCF for 4 and the 10? The 2, right? So this is 2 times 2, and this one is 2 times 5. So, giant 1, what do you guys see? The 2's. And remember, we don't need this 4 right here, and we don't need the 10. So that means we're left with the 2 there, okay? What else do we have as giant 1? You guys see it? Yeah, 1n. Draw that 1 right here for the 1n. So what's left in the numerator, guys? 2 times 5n plus 1. How about in the denominator? 5 times n to the second. And we stop right there. So we did step 1, 2, and 3. I'm not going to get into the excluded value right now. But the excluded value, what do we do here at the denominator? Set it equal to 0 and solve, right? Okay? We'll get to that in a little bit. Let's do another one just so that we can continue with that. Copy this one. Example, super Q. G over 2g minus 3 plus negative 3 over 4g minus 6. All right? So let's do step 1 together. It says factor the denominator completely. So look at this denominator, guys. Can we factor this anymore? Is there a GCF? No. Can we combine anything? No. Whenever you end up with something like that, just put it in parentheses so that we know that that stays like that. Look at this one. Does this one have a GCF? What is that? 2. And that leaves us with 2g minus 3. All right, so we no longer use this one. We use this one. So question, look up. What does this one have that this one needs? Nothing, because they already have it. But what does this one have that this one needs? The 2. So we multiply it times 2 here and times 2 there. So let's rewrite it. See what we have so far. We have 2 parentheses 2g minus 3, 2, 2g minus 3. What do we have in the numerator on this one? 2g, and over here, negative 3. All right, so since we have a common denominator, can we add? Yes, Mr. Q. What's our common denominator? 2 times 2g minus 3. Let's add. That means we're going to focus on the numerator. What do I write for the numerator? Tell your neighbor. What do I write for the numerator? Yeah, 2g minus 3. Do you guys see the giant 1? Yes? So look up. In order for us to get this giant 1 out of the way, if we put this in parentheses, what shall I write outside? Tell your neighbor. What do I write outside? A what? A 1. That is correct. So here's my giant 1. And that leaves us with 1/2. You're like, Q, just give us a pop part here already. Right? Am I right? Am I right? All right, let's do another one. Copy this one. Example omega Q, we got x over x plus 7 times x minus 7 plus 7 over x plus 7, x minus 7. All right? Let's do this one together. Factor the denominator completely. What do you guys notice? They're already factored. Is that correct? Okay, so step one done. Do we have a common denominator? Are they the same? Yeah, step one is done. Okay. So let's go to step two. Step two, we rewrite. It's already rewritten because we have the common denominator, so that's done. So all we need to do is what? Add. What's our common denominator, everyone? What do I write? X plus 7, X minus 7. Yeah, that's exactly the same for both. And then we do this for the numerator. What do we have in the numerator? X plus 7. All right. However, to do the giant 1, to simplify, what are we going to cross out? The X plus 7, but in order to do so, what needs to go outside of here? A 1. That is correct. So, giant 1. Answer, 1 over X minus 7. How we doing? How we doing? You're like, kinda, Mr. Q? All right. So for this one, look up. Find me the excluded value. And for that, we only take the answer at the end to find the excluded value. So tell your neighbor what to write to find the excluded value. Elijah, pass someone. Renzo, what do I do? Close. For excluded values, it says here, write the denominator equal to 0. So X minus 7 equal to 0 and solve. X equals 7. So my excluded value is 7. All right. See if you can do this next one completely by yourself. How about them apples, yeah? Woo-wee. Let's go. Example 1. So it says, factor the denominators completely and identify the common denominator. Question, do we have a common denominator? Yeah, we do. So that means we don't have to factor it. Okay. So what's our common denominator, people? X squared minus 9, yes? Okay. Tell your neighbor what to write for the numerator. Tell your neighbor what to write for the numerator. What? Must be nice. All right. So what do we write on the numerator? Edwin, tell us what to write. Negative X. Okay, so we got X minus 2X is negative X, yeah? And then plus 3, that is correct. All right, so we are here. We already added. So let's go to simplify. So I'm gonna write it over here so we can continue over here. Negative X plus 3 over X squared minus 9. So to simplify, what do we do to simplify? Let's see. We need to factor it completely, right? Tell your neighbor the factors for the denominator. Factors for the denominator, Marine, what are they? x minus 3, and x plus 3. Yes, that is correct. Everybody with me so far? Yes. She did square root of x is x and x. Square root of 9 is negative 3 and positive 3. Okay. This one. What is GCS, guys? If there's a negative here, that means it's a what? Negative 1. All right. And that leaves us with x minus 3. Do you guys see the giant 1? Yes? Right here. So that leaves us with negative 1 over x plus 3. And lastly, find me the excluded value. Tell your neighbor what to write for the excluded value. All right. Sean, what do I write? Yeah, the process. X plus 3 equals 0. Yeah. So subtract 3, x equals negative 3. I know what you meant. Hands, have you got negative 3? Yes? All right. Here goes another one. Copy this one. Do that one by yourself. This is almost exactly like the one we just did. See if you can do that one completely by yourself. Go. All right, should be just about done. All right, walk us through this one. How about Jesus? Do we have a common denominator? Yes. So that means we go straight to writing our common denominator, which is x squared minus 25. And if we combine the numerators, what did you write? Okay, so what do I write, though? Hold on. This is negative x, and then minus 5, yes. All right, so then he's going ahead of us, so he said take out negative 1, so hold on, let me write this over here. X squared minus 25. So he said negative 1 for this one, so I do negative 1, and that leaves us with x plus 5. And what are the factors for this? X minus 5, x plus 5, giant 1. So answer. Hands, have you got that by yourself? All right. How about excluded value? Share with your neighbor what you got for the excluded value. What was your excluded value? Ask someone. You didn't get there? Help them out, Joseph. X minus 5 equal to 0. So the excluded value is positive 5. Hands, have you got that? That is correct. Shall we crank it up a little bit? Copy this one. Example 2. A squared plus 4a over a squared plus 2a minus 8. What? She leaving? What? Plus 8 over a minus 2. All right, let's do this one together. Y'all ready? Question, do we have a common denominator? No. So that means we need to go through the entire process. Factor the denominator completely. Remind your neighbor how to factor this. How do we factor this? Yeah, let me make a space over here. Negative 8 goes on top. Positive 2 down here. What factors of negative 8 add up to positive 2? 4 and negative 2. Is that correct? So my factors are a plus 4 and a minus 2. Look at this denominator. Can we factor this anymore? No, so we just write it in parentheses. Okay. So question, does this denominator look like this? Almost. This one needs something from over here, doesn't it? What does it need? A plus 4, top and bottom. A plus 4. All right. So let's rewrite these. A plus 4, a minus 2, a plus 4, a minus 2. This one, whatever's in the numerator, a squared plus 4a. And this we have, check this out, let's distribute this, and that gives us 8a plus 32. We there so far? Yes? All right. So, now that we have a common denominator, what's our common denominator, people? A plus 4, a minus 2. What shall I write for the numerator? Tell your neighbor what you write for the numerator. What do I write for the numerator? And once again, stay with standard form. Standard form. All right. What do I write for the numerator? Rachel, go. A squared, 12a, plus 32. Okay, not bad. So far so good? Yes? However, can we eliminate any giant ones? No, Mr. Q, because I need to factor the numerator. So how do we factor that numerator? We got 32 and positive 12. Factors of 32 that when you add them give us 12 are 8 and 4. So my factors are a plus 8, a plus 4, and all that over a plus 4 over a minus 2. And our giant 1, everyone? Everybody's in shock. A plus 4. That leaves us with a plus 8 over a minus 2. Hands if you got that. All right. And tell your neighbor how to find the excluded value. Tell your neighbor how to find the excluded value. Excluded value. Yeah. A minus 2 equal to 0, plus 2 plus 2. A equals 2, so my excluded value is 2. All right. From 1 to 5, how comfortable are you with adding fractions? 4 5s, 4 5s, 4 and a halves. Okay. We're getting there. But if you notice, now we added to the process of simplifying, right? Simplifying was just one thing. We already know how to do that. Now we're adding another process for addition. And this process we've been practicing on the warm-up, okay? So, we have time for one more. Yeah, copy this one, please. Do that one completely by yourself. This is almost exactly like the one we just did. X squared plus x over x squared plus 6x plus 5 plus 4 over x plus 5. Hopefully by now you should be able to go a little bit faster on this one. But showing all your stats. All right, turn to your neighbor, let them know what you did first, and then Jesus is going to pick someone to get us started. Your neighbor what to do. All right, Jesus, pick someone. Sammy, what do we do first? Factor the denominator. So this one, there it is, 6. Factors of 5 that add up to 6. 5 and 1. 5 times 1 is 5. 5 plus 1 is 6. So this is x plus 5, x plus 1. So question, guys, to make these two look the same, what does this one need from over here? X plus 1. That is correct. Top and bottom. There it is. So my denominators are x plus 5, x plus 1, x plus 5, x plus 1. Numerator stays the same for this one. For this one, distribute the 4, so that is 4x plus 4. And now we can combine that. X plus 5, x plus 1. This becomes x squared plus 5x plus 4. And we know how to factor that and simplify to lowest terms. All right, we'll stop right there, guys. Once again, do your independent practice. Tomorrow we are going to practice in class. But try and see if you can finish up those 8 problems by yourself tonight. Have a good one, everyone. Enjoy your home play. See you guys tomorrow. Bye.